Number 61 on page 24 presents an interesting challenge for us. We're trying to find solutions for this inequality, meaning we want to know the values of x that make this a true statement. Where we plug x in to this expression on the left, x minus 2 divided by x minus 1, and we get an answer, a result, which is less than or equal to 2. When you have a fraction and a rational expression like we have here on the left, the first thing we need to notice is that that denominator might be 0. And if that's going to equal 0, that's an undefined situation. And so we have to throw those values of x out. Here, the only way we can make 0 is if x equals 1. So we immediately say that x cannot equal 1. That will not be one of our solutions. The other thing you need to remember when solving inequalities is that if you multiply both sides of an inequality by a positive number, nothing changes. It works basically like an equation. You do not change the relationship between the left and the right. However, if you multiply both sides of an inequality by a negative number, that changes the inequality and you'd have to flip the symbol around. So we really have two cases for x minus 1. When x minus 1 is positive, we simply go about our business and we solve the inequality. When x minus 1 is negative, we have to keep in mind that when we multiply both sides by negative 1, we're going to flip this inequality symbol over. So I'm going to break this into two cases, keeping in mind that x will never equal 1. And I'll solve it and then we'll put it all together. So as I mentioned, our first case is that x minus 1 is positive. If that's the case, I can multiply both sides by x minus 1 and it will not change this inequality. I'll simply get x minus 2 is less than or equal to 2 times x minus 1. I can distribute that 2 and I'll have x minus 2 is less than or equal to 2x minus 2. I can subtract 2x from both sides. That'll give me negative 1x minus 2 is less than or equal to negative 2. I can add 2 to both sides. That gives me negative 1x is less than or equal to 0. And then I'm going to divide both sides by negative 1. When I divide by negative 1, oops, I put that in the wrong place. When I divide by negative 1, remember, I have to change the inequality sign. So 0 divided by negative 1 is still 0, but now my solution for this particular case is x is greater than 0. Now, remember that we said x minus 1 is positive. That is also a constraint. That means x minus 1 is greater than 0. And in this case, I add 1 to both sides. And so x is greater than 1. Now, the solutions that are true for this case have to fulfill both of these situations. X minus 1 has to be positive, and this inequality, x minus 2 divided by x minus 1, has to be less than or equal to 2. The only values for which that will happen are values that are both greater than or equal to 0 and greater than 1. And as it turns out, those values are only the x minus 1, x is greater than 1. So the result of this entire problem, after we analyze what we found, is that the solutions here are x is greater than 1. Numbers that are bigger than 1 are solutions to this problem. That's the first piece. Now we'll talk about the other case where x minus 1 is negative. So now we're working with a case where x minus 1 is negative. Let's take care of this part first this time. If x minus 1 is negative, that means x minus 1 is less than 0. And when we solve this by adding 1 to both sides, we get x is less than 1. So our solutions that fulfill this case have to be less than 1. Let's find out how this works over on this side. Because x minus 1 is negative, when I multiply both sides by x minus 1, I have to flip the inequality symbol. So this is now greater than or equal to 2 times x minus 1. And from here we can proceed the way we did before. We get x minus 2 is greater than or equal to 2x minus 2. I just distribute there. I'm going to subtract 2x from both sides. That gives me negative 1x minus 2 is greater than or equal to negative 2. This time, I'm going to add 2 to both sides. I get negative 1x is greater than or equal to 0. When I divide by negative 1, I still have to flip that symbol over. And the result over here is x is less than or equal to 0. So while both of these are true, x has to be less than 1 and x has to be less than or equal to 0. To ensure that we fulfill both cases, we're going to want the results to all be less than or equal to 0. So the outcome of this entire investigation of case where x is minus 1 is negative is that x is less than or equal to 0. In the first case we had x is greater than 1, and in this case we have x is less than or equal to 0. So what we found is that solutions where x is greater than 1 make this inequality true, and or solutions where x is less than or equal to 0 will also make this inequality true. This is an or because there's no way a number can be greater than 1 and less than or equal to 0. That's impossible. But in these two situations, where a number is either greater than 1 or less than or equal to 0, we make that inequality true. And so this is the way we would write our final solution. Hopefully this helped clarify my work and my solutions to those practice problems. Good luck.